This is an example of a steam turbine. This is a common steam turbine out in industry. The purpose of this turbine is to transfer potential and kinetic energy provided by the steam into the rotor to rotate this shaft. High pressure steam is going to enter the inlet in what we call the T&T valve or the trip and throttle. The trip and throttle valve is going to have a tension set to control the amount of steam pressure going into the steam chest. The linkage in blue is connecting the throttle valve to your governor. The purpose of the governor is to control the run speed, which is the speed at which the shaft will rotate. If the turbine is over the run speed, the governor should slow down using this linkage the amount of steam flow into your trip and throttle valve. Past the governor, we have an outboard bearing housing. This bearing housing is going to hold the lubrication for your bearings. As an operator, you need to be aware of the temperature of your bearing, of your lubrication, which is going to have ports on this side, on this turbine, it's on this side, and this is going to allow for cooling water to enter into the bearing housing, transfer heat, and to be removed. There should always be a difference in temperature on your cooling water in versus your cooling water out. If they're ever the same, that would indicate an issue, and that would most likely be a cause of a blockage. Inside the bearing housing, you're going to have a set of bearings. The one that's located right here, closest to the rotor, is going to be your radial bearing. The radial bearing is going to keep the shaft aligned and reduce friction. It's also preventing movement in a circular motion. It's located closest to the rotor because this is the most amount of energy that's going to be exerted onto the shaft. The bearing right here is going to be called the axial bearing or the thrust bearing, controlling the movement of the shaft in this direction. The slinger ring, located right here, is going to sit loosely in the oil, the lubrication you have in the bearing housing, and as the speed of the shaft begins to rotate and pick up, this will start to pick up the oil and bathe your bearings and keep them cool. Past the bearing housing, we enter what we call the turbine casing, where you're going to have a set of seals, carbon rings, they're called carbon rings, located right here. The purpose of the carbon rings are to make sure that the steam stays inside of the casing. The steam entering through the trip and throttle goes into a steam chest. The steam chest is directing the flow of steam to a nozzle block. The nozzle block, indicated right here, is going around the turbine. The nozzles are directing your steam towards your chevrons and buckets, which are also, the steam is allowed to pass through them. And this is where the transfer of energy from potential and kinetic to mechanical happens. So the nozzles direct the steam to the buckets, rotating the shaft that is connected to a piece of equipment. I think it just died.
My husband started calling me, but it's good now.
On top of the casing, we have a high point vent. We also have a port right here where the sentinel valve will be located. The sentinel valve is much like a PSV. If there is an overpressure situation inside of the casing, the sentinel valve will lift, relieving that pressure. On the bottom of the casing, you have a low point drain. When putting a turbine in service, you're going to open your high point vent and open your low point drain to drain any condensate from your turbine casing prior to startup. You're also going to remove any condensate before you open the inlet valve. We have an inboard bearing housing, an outboard bearing housing, and an outboard seal. We also have an inboard seal located next to the rotor and an inboard bearing housing. The inboard bearing housing and seals will be located in between the driver and the piece of equipment that's being driven. So if it's a pump, the pump will also have an inboard seal and an inboard bearing housing. You have a letdown, which is also an exhaust. On this particular turbine, you have two sides. This is also an exhaust. The high pressure steam that flows through here drops in pressure when its energy is transferred. So what you have coming out will be less pressure.